Okay, so this is about the second derivative and using the second derivative test. So turn to page 17 in your packet. And recall that the second derivative being positive means that the original function is concave up like a cup. And we'll draw a picture of that. When the second derivative is negative, the function is concave down. And we're going to use these to talk about maxes and mins again. So if we draw concave up, so this one's concave up, the tangent line, whoops, I tried to intersect your graph. The tangent line is always below the function, meaning there's a minimum. If the graph is concave down, the tangent line, that was better, I intersected it, is always above the graph, meaning there's a maximum. So the second derivative test is a way to test for maxes and mins without making that table of values that we just did for the quiz yesterday. So if the first derivative is 0 and the second derivative at a point is greater than 0, meaning concave up, then the point P is a local minimum. And if this first derivative is 0 and the second derivative of a point is less than 0, that means there's a maximum because it was concave down. So we're going to try 3 problems on page 18. So there are 3 steps for doing these problems. The first step, find f prime and f double prime. The second step is set f prime equal to 0 and solve for x. And the third step is to plug the numbers into f double prime. So the values you get in step 2, those are the values we're going to plug into the second derivative. Okay, so for A, I'm going to find the first derivative and the second derivative. I'm going to set the first derivative equal to 0 and factor. All of these can divide by 3. Factor the quadratic. Oops, sorry, this should be a 16. So what multiplies to 16 that adds to -6 is -8 and +2. Sorry, I have a cold. Then we get x minus 8 equals 0 and x plus 2 equals 0. So x is 8 and x is -2. So we have to take those values and substitute them into the second derivative. So we're going to find f double prime of 8 and f double prime of -2. So 6 times 8 minus 18 and 6 times -2 minus 18. You could use your calculator. It really doesn't matter the actual value. It just matters if it's positive or negative. So 6 times 8 is 48. Minus 18 is going to be positive. This is going to be -12 minus 18, negative. So for max and min, we always write our answers as y at x equals. And then because this second derivative is positive, that means concave up, so it's a minimum at 8. This negative means concave down, so it's a maximum at -2. Now we need the y values. So we use the original function to get the y values. So let me get my calculator out. So I type the equation into y1. I'm gonna do second window, change my table to ask, and then type in those x's, and that gives me the y's. Okay, one problem down, 2 to go. Now we've got b. So g prime is 4x to the third minus 9x squared. G double prime. So I'm going to set the first derivative equal to 0. And I can factor out an x squared. So I get x squared is 0, 4x minus 9 is 0, x is 0, x is 9/4. So I take my second derivative, oops, and I want to substitute in 0 and 9/4. So g prime here, 12 times 0 minus 18 times 0 is 0. And that's going to be a problem because 0 is not positive or negative, so we have to figure out what to do with that. So then let's do the 9/4. That's positive. Let me set up to write my answers. So positive means concave up, which is a minimum at 9/4. But let's figure out this 0. 0 is not positive or negative, so unfortunately this second derivative test does not work for this situation. So instead, I have to go back to what we used to do and make a little chart. So we have to make a table just like we did to test for the first derivative with our critical values, so 0 and 9/4. And we're going to do the sign of the derivative and the original. So we have to take a number less than 0 to test in the first derivative, and then, so let's do -3, and then a number between 0 and 9/4. So 9/4 is 2.25, so let's pick 1. So in the first derivative, 4 times -3 to the third minus 9 times -3 squared is negative. And then when we substitute in 1, still negative. Sorry, there's a glare. Still negative. So that means decreasing to decreasing. So not a max or min. Sorry, I hadn't written this down here. So x equals 0 is a critical value, but not a max or min. So there is no maximum. Let's find the minimum. In the original, I'm going to put 9/4. And that is, I'll go with the decimal, -3.543. Okay. Last one. It's over here. H prime, whoa, before we can do H prime, we have to fix this. We can't take a derivative with a variable in the denominator, so we make the exponent negative. So now we can do the first derivative. And the second derivative. Let me change this back. So I have denominators. And now let's set the first derivative equal to 0. I'm gonna run out of room. I'm going to add the negative fraction to the right so that I don't have a negative anymore. And then to solve this, we can think of 1 as 1 over 1, so we can cross multiply, square root both sides, and you need plus or minus 1. So let me dig up another piece of paper. We're going to test our values in the second derivative. So this is c continued. So h double prime of 1 and h double prime of negative 1. So we get 2 over 1 to the third is positive, 2 over negative 1 to the third is negative. So positive means concave up, so minimum at 1. Negative means concave down, so maximum at negative 1. We're going to put these values back into the very, very original. That's 2. Oh, whoops, wrong spot. Negative 2. Oh, I could have left that. Okay, your homework is all of page 19. It's 2 problems. Do them now. Check your answers on Drive.